This is Geometry, Unit 10, Day 1. We're talking about two-dimensional and three-dimensional objects. A space figure is a solid that is bounded by polygons enclosed by a single region of space. So it's a three-dimensional. Space figure is a three-dimensional. We have a polygon on another side. If rectangles are connecting those, that's going to be a prism. The faces of a polyhedron are polygons. So here we have a polygon and a polygon. So the face of this particular polygon has 6 sides, so it's a hexagon. The edge of the polygon is the line segment formed by the intersection of two faces. A vertex of a polyhedron is a point where 3 or more edges meet. A base is a polygon, so that's our hexagon, is the bases that is used to name the polyhedron. So since this is a hexagon, this base is a hexagon, and we would use it to name the shape. Hexagonal prism. Oh, get the T out of there. Hexagonal prism. Alright. So we're going to classify what our solids are. To name a pyramid or a prism, we're going to use the shape of the base. So notice here we are meeting up at a single point. So we know that this is going to be called a pyramid. Here we have two bases that are parallel to each other and the sides are rectangles. So that's going to be a prism. If it comes to a point, you're a pyramid. In this excuse me, in this case it would be a square pyramid. And in this case we'd have, there's my T, Pentagonal prism. The other faces that make up this pyramid, what do you see? What are the other faces? They're triangles. The base of the polygon in this case is a square, so we named it a square pyramid. If it was a rectangle, then we'll call it a rectangular pyramid. A pentagonal pyramid. Whatever the shape of the base is the name of the polygon, the name of the pyramid. What are the bases of this prism? The bases, remember, are not always the one that you'll see it standing on. Sometimes it'll be laying on its side, like our picture down here at the bottom. But you're looking for the two shapes that are the same. The edges are all made with rectangles. So if your sides are made out of pentagons, then, the bases are made out of pentagons, what's connecting those pentagons together are rectangles. So these are polyhedra. There are several things that are not. To be polyhedra, remember, you had to be part of a polygon. Well, these shapes are not made from polygon. Here we have a circle, and it comes up, so this is a cone. Here we have a ball, baseball, tennis ball, soccer ball, definitely not a football. That's a sphere. And then here we have two circles. They're not really ovals, they would be circles. And we have the sides. The side is really a rolled up rectangle, but still that's a curved surface. So that is not polyhedra. It's not made by polygons exactly. So we get a cylinder. So these are three terms that you're going to need to know, along with trying to understand when we have a pyramid and a prism. So let's name our shapes down here. Notice that with this one it comes up to a point. So we know that it is a pyramid. So what type of base does this pyramid have? It has a hexagon. So we say hexagonal. So it's a hexagonal pyramid. And the faces that make up this pyramid will always be triangles. You can't come to a single point with a rectangle. So to make a pyramid from a polygon, it will always be made up of triangles. And then because this is a hexagon, it has 6 sides, there are 6 faces. Now, here's your typical box, a lot like a shoebox. It's made up of rectangles all over. Sometimes determining what is the base is a little tricky. A lot of people might say that the sides here would be considered your base, and then they have the long rectangles in the middle. But you could get away from any of the sides being considered the bases as long as they're parallel to each other. Each of these sides is made up of a rectangle. So that's calling it a prism. And the bases between those rectangles are also rectangles. So we're going to call it a rectangular prism. There are 4 sides and 2 bases. So here we're going to have 6 faces. Well, let me start that over. So here we have our 6 faces plus our base. There are times where the base is questioned to be a face or not. But through our calculations here, we have 6 sides and a base. So we have 7 faces. So I'm going to change this guy to 7. Sorry. This guy has our 4 plus the 2. We have 6 faces. Okay? And the sides are rectangles. A lot of times in the future we're going to call those lateral faces. Those are the ones connecting the 2 bases together. Now we look at our next shape. Here we see it's a little combination of things. We have this prism because it has a base, 2 bases made up of rectangles. Then it has this curved. Now because we have this curved piece, That's much like a cylinder, half of a cylinder. So this is not a polygon or a polyhedron. Not a polyhedron. We would call this a composite. Here's our next shape. We know that this is a prism because it's made up of rectangles on the side. The two bases are pentagons. Pentagonal. It kind of reads as pentagonal. Pentagonal prism. Here, this is not a polyhedron. But it is a cylinder. And our last shape that we have from this page, if you notice the marks on the quadrilateral, we have 2 tick marks for these sides, we have 90-degree angles on those sides, so this is clearly a rectangle, but it comes up to a point. So we know it's a pyramid. And because it comes up to a point, that's what made it a pyramid. And the base has the 4 sides. They're not all the same. So it's a rectangle, rectangular prism, rectangular pyramid. The faces are triangles. These sides that it's made up of are made up of triangles. On the next page, we're going to talk about a cross section. A cross section is if you took the top off or sliced down really any direction of any of these 3D shapes. What type of stamp would you have if you chopped it off? So here, we're slicing off the top of this pyramid, and the cross section is the stamp. It's not the figure that would fall off, but it's the shape that would be left over. Okay, a cross section is the intersection of a plane and a solid. So you're looking for this has 3 sides, so you know this would be a triangle. Triangle would be your cross section. So what would be the description of the cross section for this sphere and the plane? So once you removed this top section, what type of stamp, what shape would you be making at that point? You'd have that circle. That would be called your cross section. Here we have a 5-sided base, so that's a pentagon. It comes up to a point, so it's a pyramid, pentagonal pyramid. We run the plane through here. It's parallel to the base, which is kind of the hint here. It's parallel to the base, so it's going to turn into the same as the base. Now look here at the cylinder. We're not parallel to the base. If we were parallel to the base, we'd be up and down, and you'd get a circle. But this cross section goes between base and base. Remember, the bases are your two shapes that they have in common. Of course, a pyramid doesn't have that, but it's a shape across from the point. These two bases are circles, but when you slice this in half, if you sliced a can in half, you would get this rectangular stamp. Rectangle. That would be called the cross section. Here we have our pentagon. Has rectangles for sides, so it's a prism. Pentagonal prism. And we're going to do the cross section in between the two bases, so parallel to the two bases. So you're going to get the shape that the base is, which is a pentagon. So what do we notice about the shape of the cross section when it's parallel to the base of the solid? Here we were parallel to the base. Circle doesn't really have a base. It doesn't matter what direction you go with the circle. Here we were parallel with the base. The cross section is the same shape as the base of the solid. So here we were parallel to the base, so the cross section was a pentagon also. Here we were not parallel to the bases, not parallel to the circles, so we did not get the circle from this cylinder. Okay, here we're going to make three-dimensional shapes. You can think about this as a toothpick, and then you twirl the toothpick. What shape do we get? As we would twirl this toothpick, this would come around. This side would come around. If we were twirling this around, that's an okay drawing. Not perfect. So what shape would that be if you twirled it? We'd get a cylinder. You would have two circles, one on top and one on bottom, and then it would go around in that circular motion, showing this rectangular consistent side all the way around. In this case, we'd come around like so. Maybe that would still be considered, oh, I'm sorry. Here they wanted us to rotate it around the x-axis. So if we're going to rotate it around the x-axis, it would actually go this way. You got to pay attention to that detail. This wanted us to rotate around the y-axis. Here we're rotating around the x-axis. So if you take this triangle and you rotate it around fast enough, you would see a cone. And then here, if we spun it around in a y-axis or a vertical line, you'd get a sphere. Okay? Name the polyhedron. So, since we have rectangles for sides, we have 6 sides to the base. We know that this is a prism because of the rectangles. When you connect the bases together with rectangles, it's a prism. We know we have a hexagon for our bases, so we're going to call it hexagonal prism. And for this purpose, we're calling the faces rectangles. The faces are rectangles. Here, because it comes up to a point, what type of shape is that? We of course know that's a pyramid, and we name the pyramid based off of the type of polygon used for the base. So what shape is this base of? How many sides does that base have? It has 5. Pentagonal prism. And these faces, these lateral edges really, are triangles. Now this one could be considered a tricky one for you. Notice how you have the rectangles. You have the 3 rectangles, and those rectangles are connecting the 2 triangles together. So you know that this is a type of prism. What is the type of shape that the rectangles are connecting? What are the bases? Each base here is a triangle. So we call that a triangular prism. And our faces here are considered rectangles.